There is significant amounts of parity in how a user interacts in a particular virtual environment and how they'll interact in a physical environment.
Welcome to a new episode of XR and AI Spotlight, the show where we give the stage to the founders and makers who are pushing the boundaries of XR and AI. My name is Gabriele Romagnoli. I'm your host, and I'm here today with Tony Bevilacqua. He's the founder and CEO of Cognitive 3D, a spatial analytic platform that allows XR teams to collect spatial data, understand user behaviors in 3D space, measure the level of presence, and build better and more immersive XR experiences. Listen to these episodes to learn the missing link between retention metrics and understanding user behaviors.
We always want things like retention. And kind of what I found as a founder, just kind of exploring the product space, is that
how to use data to improve your app performance.
So if I'm a developer and I'm building a large world that a user can engage with, I can actually tell you as Cognitive 3D where the different performance problems are happening. Not only that, the subset of devices that are having those performance problems as well.
How to use the XR privacy framework to inform participants about the data the app is recording.
So I think that, providing controls, developers providing visibility to end users, the fact that they are collecting data and for what purpose, I think is really important. So we've created something called the XR privacy framework. What it does is it pops up a consent window for the end user. These are the types of data that I would like to collect. The developer wants it for the following reason. Do you accept, do you not? And then that we actually respect those signals.
And how to quantify the user presence using a presence score.
We look at a lot of different pieces, controller-based engagement, how they consume the physical space around them. We look at the 360 view and we combine that into.
And now let's welcome on stage Tony. Cognitive 3D is all about capturing 3D data. Isn't time spent or time to task enough? Why capturing 3D data?
Yeah, I think this kind of plays back into my background. So prior to Cognitive 3D, I worked as primarily in product management on a mobile analytics platform, solving very similar problems, but for the mobile space. And, I kind of came into Cognitive 3D feeling very similar, like maybe we could apply the learnings that we had in mobile and, we'd be able to come up with, good insights in the immersive category as well. And, it only took me about 3 to 4 months to realize that the product was a mismatch, that mobile did not provide the visibility that was needed to be able to understand what was fundamentally going on within these immersive experiences. And so, time spent and, these types of metrics, duration, these are the leading KPIs that you're interested in. These are the things that you might want to lift over time. We always want things like retention. We want people to come back to the experience. We want people to spend a lot of time in the experience. We want to produce in-app purchase or other types of monetization within the experiences. Those are leading KPIs. But the question is how do we understand and measure behavior within the content? How do we extract those insights so we can drive those KPIs? And kind of what I found as a founder, just kind of exploring the product space, is that there was huge gaps in the developer's material ability to understand and measure what was going on inside of the headset. If we think about the difference between kind of immersive technology and mobile technology, mobile is very passive. You have a very specific set of screens or, kind of experiential things that you might do with a really predetermined outcome. And the question is, how do we move people through those screens? How do we, stop people from falling off the funnel? When we start thinking about immersive technology, the user has agency. We're creating a reality for someone else, right? And so when you do that, the user has the ability to really kind of throw a wrench into the way that you think about your content and produce, kind of their expectations on how you're going to interact with that space as well. And so for us to provide good context to a developer, it was really important for us to capture 3D data on what was actually going on within the experience.
So, and can you give us then some experiences in which 3D data can prove much more valuable than the 2D data that people would get from other platforms?
Yeah, for sure. So we work in kind of a few key areas, right? So in the early stages of the company, we really focused on enterprise. I actually founded the company thinking that, hey, we're gonna, the rocket ship is going to take off. This was back in, I'm going to date myself here, but DK1, DK2, in the very early days of VR. I'm excited. Everybody else is excited. Rocket ship is taking off. And so we were building a gaming product back then, entertainment, consumer facing product. And we realized very quickly it was like, okay, like there is a significant amount of work that needs to get done before we're going to be able to address this particular category, in a material way for consumer facing applications. But what we did find when we started building our product is that enterprises were finding a lot of value in it. They were using it primarily for use cases like training and simulation. That was a huge, opportunity area, and we saw a lot of POCs, prototypes, and other types of initiatives going on in that category. The second one was in consumer research, and for us, that kind of broke into a few different use cases. AEC, so architecture, engineering, construction, to the left here. And with that use case, we're trying to understand how people interact with space, how they move through content, what draws and keeps their attention within that content as well. The second part of consumer research would be around product development. So you can think of like vehicle design, manufacturing, those types of use cases where it's really important to be able to measure the potential impact on a virtual item or a virtual experience and how you could use those insights to build something physical. I think that was a really interesting use case of VR where our customers found a lot of fit. And then the third piece would be in retail CPG. And so that was testing planograms, testing retail environments, how people move through those experiences, what drew and kept their attention, what products, branding, packaging, was likely to resonate with your target audience. So we saw a lot of really great opportunities in that particular category in the early phases of the company. And then alongside, so I said three categories. So the training, consumer research, and then academic research has always been a staple for us as well. We've got like 40 plus academic institutions that license our platform for varieties of different research, testing all sorts of things in a variety of different categories. What's been new for Cognitive 3D just in the last year is really being back in that consumer category. We've been helping build games, entertainment applications, lots of fitness, non-games VR. Those types of use cases have been really fantastic.
Yes, I imagine that especially the one that have a very physical element like fitness might really benefit from that spatial 3D aspect. And what I was also intrigued is you mentioned about using the spatial data to increase and optimize the performance, the game performance. How is that? Can you give some examples there or something?
Yeah, for sure. So this is something that we kind of realized really early on was, you have to maintain a certain performance standard to be able to deliver experiences. And it also is kind of underpins all the other metrics that we care about. Cognitive 3D, we spend a lot of time on application quality. And I think if you think about application quality, I think the bottom tier performance, all the rest of the blocks of the pyramid need to stack on top of that, right? And if we don't have good performance, we can't have good comfort. If we can't have good comfort, we can't have good presence and immersion within our content as well. And so performance has always been really important. So we measure things like, FPS and frame rates. We look at GPU and CPU levels. We look at different types of inputs, frame drops, other types of things that we see within the experience. But the spin that we add to it is that we collect the spatial relevance of where these things are happening. So if I'm a developer and I'm building a large world that a user can engage with, I can actually tell you as Cognitive 3D where the different performance problems are happening. Not only that, the subset of devices that are having those performance problems as well. So you can actually dig in and actually look at, let's say Quest 2s versus Quest 3s. Obviously Quest 3s have more horsepower, might see less performance problems over here. So if I can segment into Quest 3s, then I have the ability to see like, where do I need to optimize a bit further to address that massive audience that we still want to reach.
That's actually an interesting point because so often it's like maybe there are some assets that are not optimized on some areas that are particularly dense without knowing. And then it's like, okay, where is actually that frame drop, that performance hit happening?
Yeah.
So then I can imagine.
the developers knew it was happening, right? Like they know there's performance problems. People are complaining. You look at their reviews and it's like, I'm having terrible performance, refund, this game sucks, those types of things. And it's like, okay, but the contextual elements of this, of like what happened and where, beyond playtesting, recording video, or being in the room with the user, what happened, how do we extract those insights? And I think that our tools have been really focused on providing kind of a top level barometer of, is performance good or not, right? And then providing the kind of like peeling away the onion, are the tool, like being able to dig into specific elements of performance that could help you extract an insight.
Yeah, yeah. And so there was another part that the XR teams already have access to a lot of data. So as you building data analytics platform for the past years, what are the ways in which you have seen teams that could already look better at the data that they currently have?
Yeah, I think that there's a lot of legacy tools out there that, offer some of that mobile capability. So, I actually don't discourage folks from using multiple tools. I don't think it's expensive, from a performance perspective, to run cognitive 3D alongside something else. And there's a lot of really great analytics tools on the market. I mean, there's huge companies that are building, analytics capabilities, and I think that they offer, fantastic dashboards. That said, we really focus on the spatial element of how people are interacting in these experiences. What I've learned maybe in the last year or so that I didn't expect as much is that developers would like to focus a little bit more on one data set. And I think that they've expressed interest in how our spatial dashboards work and the insights that they can get. But Cognitive 3D's also had to meet all of those kind of legacy requirements as well. So we provide our own retention rates, we provide our own, DAO, MAU, kind of all these like baseline things. Because if I can look at all the spatial data, but I don't have signal around those baseline metrics, then it's hard for me to kind of make decisions with that spatial data. So I think that that's heard loud and clear. We've shipped a lot of features and capabilities around that as well. But I also kind of caution developers, because we do find that there are tools that are great out there, crash logs, all sorts of things that can give you signal on the fact that there's a problem, but they don't necessarily give you insight into where that problem is or potentially how to fix that problem. And so we see that time and again with our customers and folks that are onboarding. They'll spend tons amount of time searching for a particular issue, but they don't have the context of how that issue actually occurred.
Right. And so since also you mentioned so often that's being at the core of what spatial is how those data, how those flows, how those interactions are mapped in space. How do we visualize these sorts of data? Because our brains is usually used to seeing a line on a plot and maybe multiple lines. We could have like other sci-fi visualization, but when you have something that changes in time, and when maybe you want to split for cohorts or maybe other action and other agency that you want to have in the data, how do you visualize the spatial data?
What's kind of funny is that I always thought that the tools that we were building were way off track in terms of like how a developer might, think about data. And then it's like, okay, we got to train them on an entire paradigm on how we visualize things. But the reality is that the way that we visualize data, which is effectively a 3D reconstruction, kind of like a Matterport style dollhouse with the data overlaid on top, it's actually very ergonomic for the developer, because they get to see the data within the environment that they work every day, right? If I spend years working on a particular project and they can step into an analytics dashboard and be able to see the insights within the space that they've built, the space that they've been working on, it's actually very easy to quantify and understand. So we have a few primary products that we offer. The first one is called Scene Explorer. It's an after action review, and it's effectively a one-to-one reconstruction. So it's your entire level, how the user moved through it. It's got a timeline on the bottom. You can look at, how a user interacted individually, how they interacted across many scenes. You can do cohorts of users. So, maybe a multiplayer lobby, those types of things as well. So that's the first one. Second one's called Scene Viewer. Scene Viewer is inside the dashboard. And so that allows you to overlay the same level, but aggregate data. So You talked about cohorts, being able to split the data, ask questions. That's the DNA of the dashboard. So the idea here is that you could actually log in, say, hey, show me like all the performance drops or like where people got stuck within a particular level. We're going to overlay some heat maps, some visualizations of like where you might want to pay attention.
We have discussed a lot of about the spatial data, and I imagine that there is a lot to do with, for example, movement of the user, flows, and what objects do they interact. What about other layers of data, like, for example, biometrics or eye tracking? How have they contributed to the depth of information that you can get from the user experience?
Yeah, for sure. I think that eye tracking in particular, it gets a kind of a broad lens from folks that, this is like the biggest risk in kind of the XR category. And, it's kind of an interesting category for us. With eye tracking in particular, it's primarily the enterprise category that's actually drawing and is interested in this particular type of data. So eye tracking can give you a lot, specifically around training and simulation. We can look at things like, sorry, I'm losing my train of thought here. Can you hit me with that question again? Thanks.
Yeah. So,
Yeah.
How do you wait? Let me just get a time. Yeah. So we have discussed a lot about the spatial data, right, and how user moves in a specific environment. So how do actually data around, for example, eye tracking or biometrics, let's say, contribute to adding depth to the understanding of how the user is interacting in the scene?
Yeah, for sure. I think that eye tracking can add quite a bit to an experience. We've actually seen this most in the enterprise category of adding additional insights and additional inputs to how people are interacting within those scenes. And I think that one of the things we've noticed in the training and simulation category that eye tracking can add some really important context when it's needful, right? It doesn't work in every single simulation, but if we think about inputs like situational awareness and being able to understand, like, did a law enforcement officer comprehend the entire environment before they took action, that can be a really powerful insight to be able to understand and evaluate an individual. On the biometrics side, I haven't seen as much production interest in it. We've had some, folks that are interested primarily on the academic side on, ingesting other things like heart rate, galvanic skin response, skin temperature, those types of things. But I would say that would fall into the other two categories: the consumer research category, where we're doing small groups of folks that are going through specific stimuli that we want to understand maybe a biometric response to. And then the second category of that would be academic research. And academic research is pushing the boundaries on everything. They want the eye tracking, they want the biometrics, every signal that they can possibly get as it relates to their stimuli. Let's have it, and we'll analyze it later. But I haven't seen any of these things kind of flow into the consumer interest area. Even on the eye tracking side, I think that there's enough insight that we can garner from gaze-based tracking, positional tracking, and all the other inputs that we have to garner a good view on how the user interacted with the experience. So we haven't seen a ton of pull on consumer side with regards to eye tracking.
There is also one thing. So you mentioned about situational awareness and these other biosensors. I was wondering if you are aware, or if it is even possible to turn those data into emotions of some sort. If you are able to detect awe or fear, what can you do with it?
Yeah, I mean, honestly, you can. If you have the inputs that you need, there's definitely emotions that you can garner from it. It's not something that we do at Cognitive 3D. It's, we're not after trying to, parse, biometric sensor streams into, emotional data or something along those lines. But there are startups out there that do this sort of thing. And there's also on the academic side, folks that are exploring this category as well. From, like I said, from my perspective, we're kind of at the tip of the iceberg on the types of use cases that training and sim and consumer research are after today. And emotional insight hasn't been a big pull for using immersive tech yet. So there's that.
I just wanted to have a quick break to remind you that the recording of these episodes and many more great conversations with incredible experts are available on YouTube, Spotify, and Apple Podcasts. Just head over to my profile or the episode description, open up the link in bio, and pick your platform of choice. And now, let's get back to the show. Yeah, indeed, those things are very connected, and you can imagine also if, and sometimes it's not even just about emotion. For example, that could be, I could imagine like a meeting app, right?
Mhm.
And it's about how do people are interacting, who is that person that's being quiet, for example. And since
Yeah,
you have those information being gathered at that point, because it's not like you are in a standard meeting room, then you could start drawing like, okay, what was, for example, the vibe of the meeting, or
yeah,
who was dominant during the meeting. And
yeah,
that is, in a way, a different sets of data that you can collect
yeah.
to, because it's readily available from the
So,
XR
so
device.
you, so you mentioned a couple things, right? So, sentiment analysis, right? So being able to understand what
Mhm.
was the vibe of the meeting, I think that makes a lot of sense. But also being able to kind of like analyze, other behaviors as it applies to that, type of content as well. I think it makes a lot of sense. There's definitely a lot of surface area for machine learning, and being able to parse this information into things like attention, right? So, you mentioned like, are they kind of interacting in the experience the way that we expect them to. That problem set applies not just to training and sim and collaboration applications, but also in games, entertainment applications, and other areas as well. Are folks paying attention to the content? Are they engaged? These
Mhm.
types of things, and we try to quantify some of that. We look at things like presence data within the content as well. And when we think about presence, we're looking at all the different inputs. How are they using their controllers? How are they interacting with the content? What's drawing and keeping their attention within space? How much of the environment are they engaging with as well? And there's a lot of different ways that you can kind of parse and turn that into kind of a score to be able to understand, like, are we creating engaging content for our users?
So basically, you have a presence score that you could say
Yes.
from Cognitive 3D. Okay, then unpack it for me. What are some of the things that draws user attention and retention and gets them engaged?
Yeah, for sure. So we look at a lot of different pieces within our score. In our score, we are looking at controller-based engagement. We're looking at how they consume the physical space around them. So if you think about like a room scale-based environment, we look at how you consume that postage stamp and how you move around it. We look at the 360 view of how the user engages with the environment around them. So if they stay forward facing and stationary, it's likely that they're going to have a much lower presence score versus somebody who is fully engaged with their environment. We also look at the various inputs. So we look at things like, are they picking up dynamic objects? Are they engaging with their controllers? Those types of things as well. So I think there's like 5 different inputs that we measure, and then we combine that into a score, which is then mapped again spatially throughout your level or your application.
That's actually very interesting, because you can imagine that maybe you don't have an exact value of that, what's optimal, but you can always say, hey, right now our present score is X. And by making some changes, we could increase that value over time. And maybe people are looking more around, or they are interacting more with objects. And so consequently, their level of presence is better. And that's what the whole iterative process around data should be, right?
That's 100% correct, right? So we have the 3 scores, the performance score, the comfort score, and the presence score. And the idea is that these are barometers. You should be able to compare among your own applications. You should be able to compare among applications inside of your category. So, for example, other applications and how you might compare to that content as well. I think that that's a huge area of opportunity to be able to understand, like, is my application good? Could it be better? What is expected from me in terms of applications that are in my category as well? And I think that that's where we're headed from a roadmap perspective as well, is to be able to surface some of those insights for developers.
So basically, you also have benchmark. So as a fitness app, this is the
Exactly.
value for fitness, or
Yeah.
as a shooter game, or as
Yeah.
a puzzle game, or maybe something that are categories of this content.
100% correct. And then the other side of it from our perspective is that as we expand, and I think Cognitive's at 850 or 860 different organizations that are using the product right now. We also recognize the fact that we're going to need to dial in some of these insights as well, based off different types of content. So as we get to critical mass in different categories, we're actually spending more time on how do we need to optimize a particular category to make that insight more exact. I'll give you a quick example. We've got tons of fitness apps on the platform. They generate higher than average session time than any other application in the entire category. Um, but their input profiles are different. We actually kind of want them to be uncomfortable. It's a fitness application, right? There's certain types of inputs, like we want them to be reaching, we want them to be doing a lot of motion. So there's things that we calculate that might make people uncomfortable in different applications that are acceptable in fitness. So you kind of have to think about, what are we trying to achieve? Another example would be with our presence score, right? In a fitness application, I think the vast majority of them are forward facing, right? We're talking about like boxing or, all these other different applications, right? Um, and so in those input profiles, we're not looking behind us. We're not moving through space. We're not really consuming the full scope of our room scale. So we have to think about presence and comfort in those contexts a little bit different as we gain more apps and critical mass in our company.
Right. So there is another category that is now emerging and it's just gonna grow. I mean, at least that's my expectation, or that's many people's expectation, and that's being mixed reality.
Mhm.
How does that work actually? Because you technically have no information regarding the environment, or you have little. Do you provide extra data there? I mean, can you maybe explain me also what people can look at when running mixed reality app?
Yeah, for sure. So within Cognitive 3D, you still get the full scope of what Unity can see, right? So if you're going to
Mhm.
augment that environment with any dynamic objects or interactables, you're still going to get the
Right.
user's relative head position, their controllers if there exist, and maybe hands, how they move through that environment and how they engage. You are correct in that it's an unpredictable space. If we think about virtual reality, a very predictable environment, mixed reality, unpredictable environment. We do provide developers context around the space in general. So we do see mixed reality use as kind of an all-in. Everybody's they're doing an all mixed reality type of experience. But we're also seeing windows quite a bit as well, where you can like create a window from virtual reality into mixed reality. So we kind of have to address both types of situations. In the full mixed reality context, being able to understand like the room size and being able to understand kind of standard obstacles, right? So we do have the ability to capture things like, how big's the room based off like where the walls are. And instead of like trying to pick up like, the environmental elements of my room, I could actually pick up the obstacles, right? So being able to detect, hey, like there's a desk, or like a chair, in the middle of my play space, and maybe that impacted behavior. So I think that that's
Right.
an important way to look at it, is that we need to balance the privacy element of supporting a mixed reality developer against giving a mixed reality developer the insights that they need to be able to build a good experience. So where we've kind of landed on that is providing some contextual information around what did the space look like from kind of an abstract perspective, and that's kind of been our path so far.
So you mentioned a very good point, and that it's being privacy, right?
Yeah.
So how can actually developers stay compliant while still being able to improve the experience?
Yeah, for sure. It's an interesting category because I think that this type of data that we're collecting is much more material to end users, right? We're collecting behavioral data, how people interact with your space, what draws and keeps attention. There's lots of surface area here. I think it's really important to understand that, this is not going to be the first category of applications where developers don't have any insights. And so that's always been my path and of trying to explain this to folks, is that folks can't build optimized businesses without data, and we live in a very data-driven world. And so the question is like, what is the level of data that we can collect, and how can we protect a user's privacy on the types of data that we collect? And so it's really important for a developer to, number one, have a privacy policy that defines the types of data they're going to collect and ultimately how they're going to use that data. The OEMs, the actual manufacturers of devices, also have policies around this stuff as well in terms of how you're allowed to use the data. So, for example, using Cognitive 3D is totally fine on a Meta app, right? You can actually use that, no problem. But if you read the developer data use policy, you're not allowed to use Cognitive 3D as it relates to ads, or collecting data around, trying to monetize that behavior or something along those lines. So you have to be, conscious of the fact that there are folks out there that are putting up some, guardrails around how data can be used. And I think that that's a good thing. Another thing that Cognitive 3D has done is we've created something called the XR Privacy Framework. And so the XR Privacy Framework is something that developers can implement within their application. And it's kind of like a do not track paradigm. Like this whole idea of do not track was something that, was kind of formulated in mobile. Nobody adopted it because there was no standards or whatever. And so we just kind of thought, well, why don't we just build one? Like, why don't we build a do not track for XR? And so what it does is it pops up a consent window for the end user. These are the types of data that I would like to collect. The developer wants it for the following reason. Do you accept? Do you not? And then that we actually respect those signals. So if you turn off a particular data stream, we're not going to collect that data. So I think that, providing controls, developers providing visibility to end users, the fact that they are collecting data and for what purpose, I think is really important.
So, and for clarification, this framework, in which form does it exist? Is that a questionnaire that developers send over? How does it actually work?
Yeah, it's a kind of like a questionnaire, but it's in-app, right? So we offer a Unity as well as a Unreal SDK. It is an MIT source available, like open source plugin. The specification is kind of like it's a document, like a living document that lives in GitHub. And then the actual signals that the Unity and Unreal questionnaires provide, we actually detect those within the application and then signal our SDK to take action. So if you send a signal that says, hey, this user doesn't want to track any data, it'll actually send that signal. Cognitive 3D will intercept it and then turn off data collection.
Okay. So it's in a way automated, no fuss, no extra work required from the developer side.
Yeah, they'd have to implement the however they want to collect that consent.
Initially.
Yeah, exactly. Yeah.
So if we take a step back, because you have also mentioned about, we have talked a lot about, let's say, games and apps, but if you take a step back and we look at the real world, like, for example, as you mentioned, user research, right? Mm-hmm. Based on your experience, how reliable are those data collected from those VR simulation to make inference, to make decision on what happens in the real world?
Yeah. So there's an entire academic category around this, and a lot of academic studies actually explore this question in pretty significant detail. The short answer is that there is significant amounts of parity in how a user interacts in a particular virtual environment and how they'll interact in a physical environment. I think that the caveat there is that the environment does need to be of good graphical fidelity and quality to match the experience that you would expect in that real world environment. And there is some limitations, but I think that, our observation so far is that, if you think about vehicle manufacturing for a moment, if I produce new stimuli and show that stimuli to a user, we've shown them something new and measured their attention to something new. Right. So that's not a situation where that might end up in the physical world. Where you get into a physical type of use cases where, we're testing something in an existing space and we want to understand, what is the parity between our virtual stimuli and the physical environment. And we've seen good, one-to-one parity in those types of interactions as well. Good example would be the case study that's on our website with Kellogg's. Where we tested different planograms for a product introduction. Those are pretty solid insights.
Right. So as long as the simulation is of high fidelity in terms of visuals and in terms of interaction, what you could say is that the data that are collected from those simulation can be effectively or somehow reliably used to make decision about real world design or use cases or behavior about how the user is doing.
Yeah, for sure. We did a project recently with another customer where they were building a large facility and they needed to do wayfinding and signage. VR brought a few kind of use cases for them. First is that they could visualize a space that didn't exist. The building wasn't built yet. They were able to test a wide variety of variations because they didn't know what was going to work and what wasn't going to work. And then they were able to run a large audience through that environment and collect insights. And so what they determined was that, signage profiles that they expected to resonate with users were needed to be tweaked, needed to be changed. Additional signage was needed in certain locations. So you can use tools like Cognitive 3D to, kind of identify those insights and kind of make changes to your plans based off those insights.
So the other question is, with all these data that are fed into the system and which also developers can learn from, are there ways to kind of build predictive models and make decisions on top of that?
For sure. So I've got some sophisticated developers that have access to our APIs, and they can download their data and use it to build their own models. We obviously build our own models internally as well. One of the surprising things when we started working in the consumer category is that the headsets don't really seem to provide good visualization around sit stand, if the user's sitting or if they're standing within the experience. And it's actually really important, for a developer to be able to understand this, because they suspected, they had a hypothesis that our sitters were actually having a worse experience, lower retention, less likely to stay, those types of things. And so we ended up building a machine learning algorithm that allowed us to take different inputs that we already had. We looked at like head position as it related to height. We looked at arm positions as it related to wingspan. And different types of inputs. And we actually built a machine learning model that had about 88% parity around a source of truth. And so we deployed that. I mean, 88%, that works for me, that works for our customers. And now we have actual signal on like if people are sitting or standing in XR. And the user doesn't need to tell us. We have a good idea of if they are or not.
Right. That's fascinating, because then I think at that point you could then, let's say, further develop, enhance, and then think about now sitting and standing. But it could also be indeed how to, if you sketch an environment, then you could say, okay, based on every people that we run through environments, we could then test or simulate how people are going to interact with that environment before actually we build it, the users go through, but kind of like use this data to predict, to create models that give us an impression of how that environment is going to look like.
Yeah, exactly. And once you have that signal, you have the opportunity to kind of like slice by those segments that we talked about earlier, right? So being able to detect and understand, like, how does that feed into our core KPIs, right? Being able to take that hypothesis that we talked about that, hey, I don't think they're staying as long, that's something that can be proven out once you have the signal. So I think that there's a lot of opportunity to build machine learning algorithms around spatial data. And I think that the surface area is quite broad. We're not talking about events anymore. We're talking about behavior. So there's a pretty significant opportunity here.
So I do have another question that instead is more like very practical. And that is from a team perspective. Data can be also intimidating, right?
Yeah.
Let's be honest. And what advice would you give to teams that are starting to understand their data? Do they need a data hire? Is that the only way they could make sense of it? Or there are other ways in which they can dip their toes and start understanding?
Yeah. So, I mean, at Cognitive, we try to spend a lot of time making our dashboards as easy to use as possible. And I've kind of instilled in our own company values. Like, I think our first value as Cognitive 3D is don't present data without insight. And so you'll notice kind of like throughout our dashboard that every time we present a widget that shows a number, we tell the developer why this number is important and how they could actually improve that metric. So when we talk about something like comfort, what does that number mean? Why do I care? And how could I fix it? So I think that that's really important as well. I think that, even a small team can get value out of Cognitive 3D. I think that at minimum, in a larger team, having a product manager that's a little bit data oriented is always helpful. And then we do see the larger teams take on data hires, or they'll have a product manager that's really focused on this one key area. So that's typically how we've seen it form up. When I say product manager, I'm also talking about producer, when it comes into, we're talking about games entertainment, that type of category. But yeah, you don't need a dedicated resource to use our dashboards. I could see it getting a little bit out of control if you don't necessarily know what you're looking for, but we have services to help our customers too. And I've got a number of customers that have kind of like yielded the baton to us and said, hey, we love the dashboards, we love the data we provided. We don't have enough dedicated mind share internally to work with the data. Can you deliver us insights every 2 weeks? That sort of thing. So we've had those types of situations too.
Right.
Yeah.
So, Tony, thank you very much for this deep dive into data from indeed mixed reality to virtual reality to consumer research. So I think it was a very, very insightful conversation. Thank you very much.
Thank you very much. Thanks for having me.
It was a real pleasure. Bye-bye, Tony. Thank you really much for listening in. And remember to head to YouTube, Spotify, or Apple Podcasts and check out more insightful conversation revolving around XR and AI. And if you really like the show, please leave a review on Spotify and Apple Podcasts or a thumbs up on YouTube. It really helps me keep doing this and shine the spotlight on the latest and greatest advancement in XR and AI. Till next time.